Okay. May the Lord of Almighty God accept the souls of all the departed. Okay. My name is Engineer Surveyor Emmanuel Jan, and I am privileged to be the chairman of the Geomatic Subdivision under Civil Technical GHIE. You're welcome to our second technical presentation for the year. This evening, we are privileged to have Engineer Godfred Addai, who was my mate at King University, to be our presenter. So without wasting much time, I'd like to welcome Engineer Godfred Addai and then give him the opportunity and the floor to give us the presentation today.
Okay, thank you, Engineer. Thank you very much for the introduction. Yeah, it's an honor to be presenting to my colleague engineers today. And as you all know, today the topic will be our roles as geomatic engineers in the carbon market, which has been developing widely in this couple of years. So I will share my screen and start with the presentation for today. Okay, I hope you can see my screen. Can you confirm if you can see my screen?
Yes, please. You can see.
Oh, okay. All right. All right. Good evening to everyone, and also thank you for being here today. As my colleague Engineer Jan said, my name is Godfred, and I'm here today to present on a topic that has an intersection of climate, science, technology, and engineering, and which is mostly about the carbon market, and the critical role of geomatic engineers in making it work, especially in Ghana. And this presentation is based on the growing need for accurate, transparent, and efficient system to track carbon emissions and reductions, especially in Ghana. Okay, so today my presentation will be in 4 folds. I'll first introduce what the carbon market is and what MRV, which stands for Monitoring, Reporting, and Verification in Carbon Markets are, and some geospatial technologies that are being used in the present carbon monitoring, reporting, and verification, and our role as geomatic engineers in this environment. Yeah, so first, someone who hasn't heard anything about carbon will ask, what's this carbon market about? So this carbon market is just a trading system where carbon credits are being bought and sold, where companies and individuals use carbon market to compensate the amount of pollution the amount of greenhouse gas that they've emitted to the environment of how they've polluted the environment by purchasing a carbon credit from an entity that removes or reduces greenhouse emission. And carbon credits is just a permit or a certificate that allow the holder to emit a certain amount of CO2 gas or other greenhouse gases to the atmosphere. And typically, the one carbon credit permits the emission of one ton of CO2 or its equivalent in other greenhouse gases. And So the purpose of this whole carbon market is just to compensate for greenhouse emission, or in simple terms, just to help reduce pollution to the environment, to the air, and also to help the climate change policies that has been put in place. And also the carbon markets is, as I said, is just a trading system where credits are being bought, and the whole system is being brought in order to have impact on or encourage emission reduction and support sustainability efforts. So there are two types of carbon market that we have in the system. There is one that's called the compliance carbon market, which is regulated by the government. So it's in the case that companies are being given a limit of emission, or a limit that they can do a pollution, or they can emit greenhouse or CO2 gas in the atmosphere. And participants trade carbon allowance permits under cap and trade program. And the other type of market is the voluntary market, which is not regulated by any government, and companies or individuals voluntarily buy carbon offsets or carbon credits to compensate the emission that they are doing. So in this case, they don't have a limit. They can just do emission as they want, but so far as that they buy a carbon credit, or they buy a carbon offset to compensate this. And this type of market is where money is really inside. So the compliance carbon market and the voluntary carbon market intersects in a way, because they have the same aim, and the common aim is to just reduce greenhouse emission and enhance sustainability. So you may ask why are carbon markets important? I think I've given a gist of why carbon market is important. Carbon market is crucial in addressing climate change, and by putting prices on the amount of carbon that you emit in the environment, or the amount of pollution that you do, kind of creating financial incentive for businesses and countries to reduce their carbon footprint and invest in cleaner energies. And they offer a cost-effective way to achieve climate targets by allowing emission reduction to occur where they are affordable. And they also encourage organizations to reduce emission and invest in clean technologies. And for developing countries like Ghana, they are also a source of climate finance and green jobs for technology transfer. So because this is a whole market that involves transaction, it's important to have transparency and credibility in this whole carbon trading. And the reason for this transparency and credibility is to ensure that the motive of this whole market that is trying to help climate change, or have impact on climate change, is being felt. So to ensure that the offset represent the actuals and additional emission reduction, and also just to build trust, so that in every market it's better to have a trust. So by having reliable data to attract participants, or increase the market liquidity and meeting standards, and also prevent greenwashing and fraud. Greenwashing is in a case where is when a company or organization or a project falsely claim to be environmentally responsible or sustainable without any reaction. So it's important to have this transparency and credibility just to avoid this greenwashing, and also something called the junk carbon credits. That's fraud, and also drive fair pricing, because there's money involved, because the amount of carbon that um, a company sells or a country sells to a company, there is a price on it. So to regulate the market and drive a fair pricing and have a high integrity credit and then premium prices. And in order to have this transparency and credibility in the market, there is a system that is normally used in this carbon market, MRV, that's monitoring, reporting, and verification, in order to ensure that there is transparency, credibility. There should be monitoring of the markets. There should be reporting on everything, and every information that is being put have to be verified. So I'll be using the term MRV a lot. MRV is just monitoring, reporting, and verification. And monitoring, reporting, and verification in this context refers to the digital monitoring, reporting, and verification. There are some cases that you see DMRV. That's the same. It's just digital monitoring and reporting. So this whole system, the MRV system, is technology-driven approach that is being used in the carbon market, just to ensure transparency and accuracy in efficiency in tracking emissions, the greenhouse gas emissions and reduction. And the key component of this MRV system, it's monitoring. And monitoring is just the use of digital tools such as IoT sensors, satellites, drones, other data collection technologies, just to monitor the emission that has been done by an individual or a company and its impact in real time or in near real time. And reporting also, it's very important if we want to ensure transparency and credibility. There should be reporting on everything that's being done. So in this case, automation of data processing and generation of reports based on the data collected, and standardized formats for easier validation and compliance with the carbon credit protocols. And verification. Verification is also very, very important, because independent validation or use of reported data using digital tools and algorithm often supported by blockchain, just to enhance the trust and fraud. And in this whole system, the name that pops up is Vera and Gold Standards. They are kind of the rule makers or satisfiers in this whole carbon market game. Okay. So I'll be talking about some of the geospatial technologies that is being used in this MRV system of ensuring transparency and credibility in the carbon markets. And we in the MRV monitoring, reporting, and verification, digital tools like satellite, drones, and other sensors are used to track land use, forest growth, emission in real time, and then report and verify the data to prove the emission actually happened. And MRV today is being driven deeply. Is being deeply tied to geospatial technology, because most MRV system that's being used to monitor to do monitoring in carbon in the carbon markets use a lot of geospatial technologies. And some of the geospatial technologies that are being used are satellite remote sensing that's mainly used when we monitoring larger scale carbon projects or environmental projects, and also the satellite remote sensing, not only optical, multispectral, and LiDAR. That's the GD LiDAR, which is being used in the carbon monitoring to determine to do the biomass calculation, and above ground biomass calculation will come into that. And also another technology that is being geospatial technology that is being used is the area imagery. That's the drone imagery, which keeps high resolution images and give more details and insight on forest conditions. And in some cases, they are being used as to augment. They are being used to augment satellite remote sensing data, and also LiDAR technology, which facilitate precise measurement of the forest structure and aid biomass estimation and calculation. And also there is a new technology where terrestrial LiDAR is being used to do digital twin in order to help to calculate the density of the forest, and also to measure the weight of the trees for biomass calculation. And also the last but not the least, the geospatial platform, because all these data that I mentioned, satellites, data, area imagery, that's the drone imagery, LiDAR imagery, they are being processed and being put on a geospatial platform. And this geospatial platform helps in reporting, because these data are automated to create reports in real time, and to support, in order to support monitoring and reduce for REDD+, which is reducing emission from deforestation and forest degradation projects. Okay, so satellite remote sensing in carbon MRV. So satellite remote sensing is being a game changer in this carbon MRV, the monitoring and reporting verification, especially in large scale projects. And large scale projects is being very useful and cost effective, and it helps to monitor carbon stocks and flashes, and it also supports carbon projects and national greenhouse gases inventory and compliance with climate agreements such as the Paris Agreement, the Article 6, and the REDD+. Yeah, and as I mentioned, there are various satellite sensors that are being used in this whole carbon monitoring. Optical or multispectral sensors such as the Sentinel-2, which gives a 10 by 10 resolution, and also Landsat 8 and 9 and Planet Scope. These optical satellite helps to know the land cover classification, and also gives an NDVI health of the plants. And all these parameters are needed when you are doing estimation of the carbon potential of an area, or basically calculating the biomass of a carbon project, or of a forest. And SAR, the synthetic aperture, that's the Sentinel-1 ALOS Plaza. It's normally used to augment the multispectral or optical satellites such as the Sentinel-2, because we know that the zone that Ghana is in is a tropical zone, and mostly in seasons like this, there are a lot of cloud covers, and what of if you want to do some monitoring within this condition, like rainy season where we know there's a cloud cover? That's where the SAR comes in. The SAR is within Sentinel-1 and ALOS Plaza, which can penetrate through clouds and help deforestation. So with SAR, there is no limitation to the monitoring, because you can't say it's the place is having a lot of clouds, so you can do the monitoring with the augmentation or with the combination of the SAR and the optical multispectra. You are able to do your land cover classification in order to use it in the monitoring, reporting, verification of the carbon. And also LiDAR, there are some LiDAR sensors. The GD, that's the Global Ecosystem Dynamic Investigation Sensor, which is being mounted on the International Space ISS, and it's a groundbreaking satellite LiDAR system designed for high-resolution 3D forest structure managing. And this has been very critical in carbon stock estimation, biodiversity studies, and climate change mitigation. And it's having a 2-month revisit time, so it's revisit the same points within the 2 months, and it's having a resolution of a 25-meter footprint. That means a point on a 25 by 25 by 25 meter. And it's being used to get the forest height and biomass estimation in order to get a good carbon estimation or a good carbon biomass calculation. You have to get the forest height, and if you are doing a large scale project, you will need this satellite to help you to get these parameters for your biomass calculation or estimation. And also hyperspectra satellite are also being used in the monitoring and in the monitoring of carbon, which provides a detailed carbon analysis, which is mostly biochemical analysis. That's when you want to go into more details into the carbon analysis. Okay, carbon monitoring using the satellite imagery. One will ask how is carbon monitoring done using the satellite imagery as mentioned. So satellite imagery has significantly the accuracy of satellite imagery has increased, and the scalability has increased the accuracy and the scalability of carbon monitoring for large scale forest and environmental projects by leveraging on remote sensing technologies, as I mentioned, the satellite LiDAR, the SAR, the optical and the multispectra sensors. So satellite images are being used for monitoring carbon through measuring of baseline. The measuring of baseline, we call it baseline mapping, where satellite is being used to create an initial map of a project, including the forest cover, the density, the land use, the historical deforestation and degradation pattern. Because normally when a carbon project is being done, you want to analyze to know the historical degradation pattern of the forest to ascertain that the place that you're choosing will be good for the carbon project. That's basically a feasibility studies. And in these cases, satellite data, their data are the best because they give you historical data, especially when you're using the Landsat Sentinel. They can give you a good historical data of the place so that you can know the degradation pattern of the place. So with this, it helps to get a baseline mapping of for a carbon project, and also carbon stock estimation when you want to do a carbon stock estimation. Satellite helps us to estimate biomass. So the relationship with biomass and carbon is, we all know that biomass is the organic materials in plants and wood. So it's the energy that is being converted into in wood. So, and there is a theory that if you take one biomass, half of it contains carbon. So when you calculate, you do calculation for biomass, 0.5 of it is just the carbon in it. So satellite helps to estimate biomass and carbon stock by analyzing the vegetation cover, the tree type, the tree height, and the canopy estimation. Um, with with um, with this satellite data, it will help you to get tree height or the canopy estimation of a forest, which it's essential in the calculation, and tree height, which is essential in the calculation of a biomass or estimation of a biomass of a carbon project of a forest. And also monitoring changes over time, because if there is an existing carbon project, or there is a forest that is being monitored for its carbon potential, or is being used as a carbon project, there have to be monitoring going on. And the best technology for this is satellite, especially the Sentinel, which its revisit time, is the best. And regular satellite imagery captures the changes in the project, and such as the forest growth, deforestation that has happened, land use changes, and normally high resolution satellites, which are commercial satellite, that's Maxa, are also being used to get more, if you want to see more details of what's happening on in there. And detecting leakage. So leakage occurs when deforestation or emission are displaced to areas outside the project boundary or the carbon project boundary. And satellite imagery can track nearby regions to ensure that the carbon savings are not offset by increased deforestation elsewhere. Okay, carbon monitoring and reporting using satellite. So quantifying carbon sequestration. That's you can use satellite to derive data on the forest area and growth. And growth are used in conjunction with field measurements and models to help calculate the amount of carbon sequestrated or emitted or avoided within a carbon project. So satellite enables accurate, transparent, scalable carbon monitoring for verification and reporting purposes by combining various satellite sensors, not only one sensor, combining the multispectral with the SAR. I've explained in case that there's a cloud cover, and combining the LiDAR in case that you're doing the biomass calculation where you need the tree height and height information, and all together with AI and analytics to help you monitor, verify, and report on a carbon project. And data from satellite are also integrated in an MRV system to ensure transparency, because if you want to ensure that this carbon potential that has been put ahead, that this project will be yielding, is it true or not? This MRV system will help monitor it and see that, okay, the estimation that was done is right on track and everything is transparent. If there is a degradation of forest on the project, the system will be able to alert it, and accountability can be done for it. So, and third party verifiers analyze satellite data alongside field data to validate the carbon the carbon credits. And area images and LiDAR for how area images and LiDAR are also used for carbon monitoring. So for precise carbon project development, high resolution drone images and area LiDAR are increasingly combined. So there are cases that satellite data, area images, and LiDAR are being combined for a large scale project, because maybe you want to get more information on or accurate or verify that satellite information that you're getting it's true, or like ground truthing on ground. So ground truthing, terrestrial LiDAR, area or UAV sensors are being used to do the verification. So the combination of these area images, LiDAR, with satellites is just to enhance the accuracy and scalability and the cost efficiency of biomass estimation and carbon potential assessment. So with kind of combining them doesn't mean that maybe UAV you fly the whole project, just to fly a section or just take a sample of the classes and or scan the classes in order to get an estimation of when you get a type of class, how the density is, just for ground truthing, in order to get an accurate biomass estimation. And the technologies that are being used are for UAVs, RGB and multispectral, less than 5 cm resolution, and that's on-demand flights based on the analysis that you want to do. And the role that this RGB and multispectral data from the drone plays, it gives a tree-level monitoring, like species identification, health assessment, and also it helps in ground truthing also as well. Area LiDAR also helps create a 3D structure of the forest in order to calculate the tree density of the forest. And these data are between 10 to 5 points per meter square density, and it helps in modeling or in calculating above ground biomass, and also canopy height in order to use for your biomass estimation. Ground LiDAR, which TLS, that's the terrestrial LiDAR scanning. Terrestrial ground-based LiDAR provides ultra high resolution 3D forest structure, which enables precise stock quantification at a plot level. And also it bridges the gap between field measurements and the example is the manual tree survey. So the picture below, this how manually the tree measurements are being done. Like they take sample plots and they measure it, but with the use of geospatial technology such as the TLS, the terrestrial LiDAR scanner, you'll be able to scan an area, and with one scan that will be between 5 to 10 minutes. You'll be able to create a 3D of the forest, which will help you do a digital twin of the forest, which will help you analyze a lot of trees, which will help you do a lot of tree surveys as compared to the manual method of measuring it, because in 5 minutes you can capture a lot and you see the measurement almost 90 by 50 meter. That means there's a lot of tree that you can cover as compared to the manual way of tree surveying. Also, one of the geospatial technologies that are being used is geospatial platforms, because all these data that we get from the satellites, we get from the UAVs, we get from the LiDAR, it cannot be used without, or it cannot help the MRV without the geospatial platform. So geospatial platform, it helps integrate, so it integrates GIS, remote sensing, and spatial analytics, and it's transforming a carbon MRV by giving accurate, transparent, and scalable tracking of carbon stock. So um, there are existing geospatial platforms that are being used in the carbon monitoring and reporting and verification, which I think in Ghana there is not a lot, but I can mention that in Ghana there is one Arcadia system that is incoming, which is capable of doing the above ground analysis, ARR carbon potential calculator. It can give you historical forest loss, tree count detection, and also land type distribution analysis, which all helps in the carbon monitoring and reporting. Okay, so finally we come to what are our roles as geomatic engineers in this whole carbon market. And I would say that we have a huge role based on what I've explained, because all these geospatial technologies that I explained, that I said it helps the MRV it helps the accuracy and the transparency of the MRV system, are all geospatial systems, and that's what we do. Talk about remote sensing, that's the satellites, LiDAR, the SAR. Talk about photogrammetry, that's the UAV, the terrestrial scans, and talk about geospatial analysis, that those are the GIS that we do, GIS platforms and geospatial platforms that we do. So looking at this, we have a huge role as geomaticians in the carbon market, and this is where we geomatic engineers, we come in in the carbon market through the monitoring, reporting, and verification. And we are not just mapping the land, we are mapping the future of climate solutions, and our work also ensures the accuracy, transparency, and credibility of the carbon data, and whether it's collection, it's spatial analysis, or the MRV system design, we make the carbon market trustworthy and efficient. And looking at how the carbon market is growing, and the analysis that how Ghana is going heavily in this carbon market, it's essential to raise our awareness of our role in it and take advantage of it as geomatic engineers in the carbon market. So as geomatic engineers in the carbon market, we play a crucial role and a multifaceted role in the MRV of carbon, especially in the context of climate change mitigation and carbon markets. And our expertise in geospatial technologies and data analysis is fundamental to ensure that there's accuracy, transparency, and credibility of carbon accounting. So another role is just the data acquisition part. As I mentioned, the data acquisition part through satellite data, through going into the field to do scans, through area mapping. So geomatic engineers, we employ remote sensing technologies, including satellite imagery such as Sentinel, Landsat, Planet, Labs, and area photography, especially drone-based system to collect comprehensive data on land cover, land use, and vegetation health across vast area. And satellite imagery, area photography, LiDAR are all essential in assessing forest condition and the monitoring of the the carbon stock, or in estimation of biomass, of biomass calculation. And all these technologies these are our expertise. Satellite imageries, like remote sensing part, in area photography, that's photogrammetry part, in LiDAR, which I'll still classify as photogrammetry part, that's more of the scanning. And these technologies are which the techno or the data that makes the MRV system works, and that makes the carbon market credible. So we in the data acquisition part for the MRV, we play a huge role in that also. And the geospatial data management and analysis in market. So we geomatic engineers, we utilize GIS database to efficiently manage spatial data, enabling informed decisions regarding carbon stock assessment and land planning in carbon market. So through spatial modeling that we do using GIS softwares and other programming softwares, and also quantification techniques. We geomatic engineers, we facilitate the analysis of greenhouse gas emission and we help also stakeholders to understand the implications of their environmental practices and policies. And talking about the whole MRV system, we help with in order to monitor something, you have to have a baseline, and this baseline is being done especially using satellite images. That's where we come in. So establishing a clear baseline is essential for carbon management and allow accurate tracking and emission and carbon sequestration over time. And doing this, you need satellite data such as the optical multispectra, the LiDAR sensors or on satellite. You need this data to do this baseline, and that's what we do, and that's where we come in. And also continuous monitoring of changes to ensure ensure emission reduction are verified, enhancing the credibility of carbon market and enabling stockholders to make informed decisions. So in order to create a credible carbon market, monitoring of the emission, it's essential. And in monitoring it, you need a system that regularly takes data, and that's a satellite that like revisit the area a couple of times so that we'll be able to analyze the changes in order to ensure that the emission the carbon project or the forest or the carbon market is being verified. And also integrating AI, machine learning into the MRV process significantly improves data accuracy and allow real-time analysis of the carbon stocks and facilitates more effective climate actions. So in summary, we geomatic engineers, we play a crucial role in informing land management and supporting effective climate policies by leveraging on these geospatial technologies or geospatial data which helps enhance strategic planning and promotes sustainable practice that positively impacts the environment. So in summary, the industry experts, based on things that has been done elsewhere in other parts of the country, are saying we geomatic engineers, we are essential for effective carbon management and ensuring accurate data. So to conclude, carbon credits are a powerful tool, but only if they are based on solid data and science. And geomatic engineers are we are the silent force behind the credible markets, because you need a solid data that's more of geospatial data for this MRV system. And Ghana and Africa at large has a chance to lead in this space, but only if we invest in technology and training, and also creating an awareness of what we can use our technology or our knowledge to do in this emerging carbon market. Thank you for your time and your attention, and I hope this session has shed more light on how geomatic engineers can play a transformative role in this carbon market. And I would love to hear your questions, your comments, or perspectives.
Okay. Engineer Godfred Addai, thank you so
Engineer
much.
Jan, welcome.
Yeah, let's give a round of applause to Engineer Godfred for that wonderful presentation. Thank you so much. Very insightful. In fact, there are some of the things you made mention of, and this is my first time of hearing some of them. Okay, so before we come to the questions, I would like us to acknowledge the presence of Engineer Surveyor Dr. Peter Damwa. He has been confirmed as the head of department for the Geospatial Science at UNE. So let's acknowledge his presence. He's our immediate past chairman too. Engineer Dr. Prof. Damwa, please let's hear you. We just want to acknowledge your presence. We know you are here with us.
Okay. Thank you, Engineer Chair.
Okay. Big congratulations
wonderful.
too.
Yeah, thank you very much. Thank you very much. In fact, I've been following the presentation and it's very nice. Like you said, yeah, some of us, this is the first time we are maybe having the opportunity to hear more about carbon market and carbon credits. And we are happy to have the presenter today to explain the basic role that geomatic engineers can play. So we thank you very much, and we thank you also for organizing this program for the subgroup. So thank you all.
Thank you so much. Thank you. Let's also acknowledge the presence of engineer surveyor Dr. Katsina Omega. He's currently the chairperson for the LSD under GHIE. Engineer Dr. Katsina.
Thank you. GHIS rather. You are GHIE.
Sorry, GHIS. Sorry.
Yes.
LSD. So Land Surveying Division, GHIS, chairperson.
So thank you very much. I'm also excited to be here. When it's time for questions, I have one or two questions to ask, but I've learned a lot also today. Thank you.
Fantastic. Thank you so much. Please, is Surveyor Alabi here? Today, it seems I haven't seen him. I don't know if maybe he's using a different ID. Regional Lands Surveyor, Ashanti region. I think he couldn't join us this evening. Okay, so the floor has been open for questions, any add-ons. If you have any question, kindly raise your hand and then we'll call you so that we can learn more from the presentation. The floor has been opened.
Okay, so let me ask a question. The carbon market in Ghana, are we part of the carbon market, the global carbon market? And where are we doing our measurements? So let's take, for instance, a campus like Professor Damwa Nana's campus, the whole campus. They want to go into green energy, so they are reducing they are going into solar and all that. So I feel that they are not then they are reducing greenhouse effects. Are they able to do some measurements in that sense So I'm wondering how big how big a market should you have before you can do a measurement, or how small can in terms of spatial whatever, how small should it be before you can do any measurements? I don't know whether I'm clear with that.
Yeah, and I understand your question. So first, I will answer by in Ghana we have what we call the carbon registry, which is under the EPA, which kind of verify when you want to do a project on carbon. You go to them, but they are also third parties that verifiers, or I'll say Core Vera and Gold Standard. Before you do any carbon project and you want it to be in the carbon market, they have to do like some analysis or certify you that okay, this project can be used as a carbon project. So there have to be some verification to be done in order to ensure that okay, this project, or this, like for example that you made, can be classified or can be used as a carbon project. So it's under the jurisdiction of the Ghana Carbon Registry, and also the third party or verifiers like the Vera and Gold Standard. I hope I was able to answer your question.
In terms of the size,
Yeah.
she asked about the size too. At
So-
what point, what should be the size before?
For the size, it doesn't really matter the size. Is the impact. For example, in Ghana now, there is a project which is called the Cook Stove project, which is a project between the Ghana government and the Swiss government, which they are kind of sharing stoves in order to help reduce the use of charcoal and firewood. And you might think that it's like a small project, but the kind of impact that it was having brought a lot of carbon, like a lot of carbon credit to Ghana. So I can't pinpoint whether this size is based on the impact, and also on the jurisdiction of the third party verifiers or the carbon registry to say that okay, this project, you can say it's maybe under 1 kilometer by 1 kilometer, but the impact of it will be a lot than maybe 10 kilometer by 10 kilometer. So it's based on the registry or third parties like Vera and Gold Standard to ascertain that this one can be under the carbon market or under this scale. So there's no like a figure for it.
Okay. All right.
Mr. Godfred, can I come in?
Yeah, you can
Yes,
come in.
please.
Yeah.
Yeah. So when you're done with the registration with the EPA, the Carbon Office, one, you would have to have a buyer who is ready to buy. So no matter the size that you have, if the buyer is interested, that is.
Please, sorry for interrupting. We don't know who is talking. Kindly introduce yourself, please.
Oh, sorry. I'm Chief Lesampo Sasa.
Okay, our vice chair. She's our vice chairperson.
Yeah, so
okay, go ahead.
It's the interest of the buyer. What the Carbon Office does is that it gives you approval for the project you are doing. Then the Gold Standard of Vera would do a verification for the third party, that's the buyer, if the project is how do you call it, carbon credit worthy. Yeah, so that is not really about the size. The problem is that many people haven't also seen that just a simple reservation of a farmland can can be seen as a carbon project. So it's not really about size, as Godfred said. It's about impact, and if there is a ready buyer to buy that carbon that you are offsetting.
Okay. Engineer Terra Antwi. Engineer Terra Antwi has asked a question that she's asking about digital twins. How can one go about this to capture and twin plant phenology?
The question again, sorry.
Just I saw I saw a digital twin somewhere in the presentation. Yes.
Yeah. Let me go. Yeah, this one. So what was the question about?
This digital okay, Yinatara, please can you respond?
So there's that somewhere in the presentation for carbon market. How can one go about to capture the data twin and plant? So the digital twin, as you see here, it's being captured using the terrestrial scanner. That's a sample here. This is, I think there's a trembled scanner. So with that one, you just have to. So for example, if you want to do a data twin for a forest or a large project, you don't need to how do you call it? You don't need to scan the whole forest. You just need to take a sample size of the forest, and you scan it. So with this scanner, it's when you put, like how it's being set up, you leave it will just rotate around and scan wherever it sees. I think it's like 50 meters radius, and everything within it will see 360. So it will produce something like this that you see, the digital twin here for you. I don't know whether Tara, I've been able to answer your question well as you wanted.
Yeah, sorry, I think you did for the most part. My concern was, let's say, for plant phenology, you have a plant coming as a shrub before it gets to like the maybe the final stages, you know.
Mm-hmm.
So the height will keep changing. So for a digital twin, how do you intend to capture that? Yeah.
So that's why the monitoring that you're doing, it's not done like a baseline. That's why there's monitoring that you do it with a period, because maybe the digital twin that you do now is just for estimation, to estimate, okay, this, because you know the type of plant, and you just using it to calculate the density of trees within there, and also the stem, because you know that, okay, this plant within this year, this will be the width and this is the density. So it's an estimation, but in order to get an accurate one, so you have to be monitoring it to compare to your estimated value, in order to know, okay, definitely it won't be the same. There will be changes. So as you said, the stem side will change. So that means the data that you collected can't be used for some time. It will be just used for the time that you calculate. But that's why you have to have an interval of monitoring or taking data if you are using this method. So mostly this method is used for estimation purposes. And if you also want to use it for more monitoring purposes, you can use it, but that means you have to be taking it within some time interval.
Okay, thank you very much, Godfred. Yeah, it's very informative. Thank you.
Seeing Engineer Asia Zibrila, you've joined us from Canada. Thank you so much. She has also asked a question that what are some of the specific tools or software programming languages we can use for satellite or drone imagery analysis for carbon stock estimation?
So yeah, so the tools I will start mentioning some of the tools, but it's not static. It's also based on what do you want. Like for example, this TLS came about when people saw that okay, I mean measuring tree density instead of going to the forest to count it. Okay, there is a technology that we use to scan buildings. It can be used in the forest, but some of the existing tool that is being used here is the terrestrial scanners as you see here. And for the satellite, I mentioned that some of the satellite that are being used, Sentinel-1, Sentinel-2, Sentinel. I think I can go to that slide if Asia missed it. Yeah. So these are some of the satellite that is being used. So I said the optical one and the SAR one in case that there is a cloud cover. So the SAR augments the optical one. And also there is a LiDAR which is having like a resolution of 25 meter by 25 meter. That's for 1 point. So it takes 1 point for 25 meter by 25 meter, yeah, of an area. And the softwares that are being used, definitely GIS softwares, and for programming languages, because geospatial platforms are being built. So it can be mostly, we know that most of our geospatial platforms that are built are Python, and also these geospatial softwares, they are API that is being used, and mostly the API that are used in the geospatial platforms are the Google Earth Engine API, because it's having a lot of special satellite data already in it. So, and for the drone one, the drone is based on the area that you're going to fly, because for forested area, I would say it's not advisable to use a fixed wing drone, because you need a huge space for takeoff. Maybe you need a multi router such as the M300. And also M300, you can also take RGB images and LiDAR, because you'll be having you can attach RGB sensor to it, which is the P1, and you can attach a LiDAR in case that you want to do a UAV one. So for the tools, yeah, and for the drone images analysis, yeah, photogrammetry, images that are around Agisoft, Pix4D, and a lot. So that's, yeah, for these there are a lot, but these are a few that I can mention.
Thank you so much. I'm sure we are learning. Please, more questions. Okay, so Dr. Tina has raised her hand.
Yeah. So let me lower my hand so that I can ask the question. Now, I
Please
find
go
this
ahead.
very interesting. On a lighter note, so I'm in Africa and I have a lot of let's say forests and all that. Then I tell someone who is in, let's say, Europe, will develop his country, make sure that every place is paved, and then we'll say that, okay, I'm coming to buy your green, which is in another part of the world.
Yeah.
And then, so that's how the market works, right? I'm coming to buy your green, and whatever, to say that I can keep on doing my pavement development just because I have bought your green. Is that how it is?
Yeah.
I find it quite interesting.
Yeah. So yeah, that's
Government,
I
can I
think
come
that's.
in there?
Hello. Yeah.
Yeah,
Go
hello.
ahead,
This
please.
is Chiefless. Government, can I come? So it is not just about the greens. For the Cookstool project that he mentioned, one of the aims is that when you go to the remote areas, these firewood that they use as fuel for cooking. Now it's the emission that it brings out health-wise and in terms of the amount of carbon it releases to the atmosphere, right? So they bring in stove interventions that will lower the carbon emission. That is also another side. So someone can decide to say, okay, I'm sharing an intervention, a stove intervention to all these people, but I produce the stove. I don't have the money to produce all the stove for them. So I seek how do you call it, a carbon credit fund. And once it is established that my stove is able to decrease the emission because maybe the fuel that I'm using in my stove is less, the project is counted credit worthy and I get the money to fund such a thing. So it is not just about somebody coming to pay for your green and saying you don't develop, but there are also indigenous technologies that are harmful or doing a certain amount of emissions. We bring interventions or better ways of cooking, as even the LPG gas is an intervention. So if let's say we are supplying LPG system for everybody to cook instead of the coal pot, then I can say that, okay, the stove that the LPG gas system that I brought is reducing emission. So I seek a funding and do my distribution. And that is also a carbon credit project.
But
Great.
to answer Tine's question also, we have the green. We need the money also for development. They are developed already. We need the money for development. And also we growing the green is not helping them also as well. It's helping them because if we don't grow the green and we also start developing, the whole world that will suffer. They won't suffer alone. So it's better that we grow our green, protect all ourselves and get the money also for development.
Yeah, I attended a conference some years back, and then there was an argument between the developed world and the developing world because they are like, you have made your country beautiful by putting all these nice buildings and skyscrapers, and now you are saying those things are not good. We should keep our green. Let's also develop to your stage. Then we'll all learn and then come back and start destroying. That's on a lighter note. It was an argument that came at, but
yeah. But
probably
another argument is even now the West are doing a lot in that, though they are developed, they are buying credits in developing countries, but aside they building a lot, they are also, as Theo said, it's not only the green that also helps the reduce carbon emissions. They've introduced the electric car systems in the whole of Europe that they have reduction discounts for even if you buy electric cars, and the companies are now being monitored on how they use, or companies are now being forced in this carbon whole game. So it's not only the green. The green is just a part. So they are also doing their part also to help. But because we have the green, they thought, okay, we need the money and we have the green, so why not? So it's a win-win for all of us.
yes. Thank you.
Yes, we have some more questions. Engineer Zanita, I've not heard your voice this evening. Engineer, are you there? Okay, so the floor is still open for more questions. So where are Deborah? Joseph, Deborah, do you have anything for us?
I think there is DP Apedu, the hand is up.
Okay. Oh, sorry. Okay, please go ahead, sir.
All right. Thank you very much, Godfred. Thank you for the presentation. Good. For me, this is maybe the third time I'm hearing about this. And then I've been asking myself question. First question I want to ask is that by now, I heard engineer Geospatial saying that it is the availability of a buyer. So as an individual, a small business, can I get up and then do all the measurements you are talking about and everything? And then I go out there to the market that, oh, I have this at this particular area, I have this carbon capital, or this is what I have, and will I be able to get a buyer? And then my second question is that looking at this environment, how does it contribute to Ghana's GDP in terms of how much we make as the country over the years? How much have we made? And then the future, how you spoke about the future prospects, how it's going to help us. So I want to know, as an individual, small business or an engineer, how I'll be able to capitalize on that, and where do I get to benefit as I move along, so that if we have to go into it, then we'll be doing more measurements. Because, and then my third question, in terms of measurement, let's say I have a 4-acre land that I want to go into agriculture, and because of this, I want to go into agriculture and do some tree planting. You spoke that in terms of the biodiversity, it's about 50% of the organic
the biomass.
The biogas, yes. So
The biomass. Yeah.
Can we get up and intentionally create this scenario just to make money? Maybe I have a 4-acre, 5-acre land, and I go into certain tree planting, and there are some of the things that I have to have from an agricultural point of view to bring it back to make some money for myself. And how long will I take to do all these things? So this is some of my.
So this carbon market that we're talking about, I would say, in order to do a carbon project that is worthy of that money, it's kind of capital intensive. In a way that is not, sometimes it's not you using your money. There are organizations out there waiting for a proposal to see that, okay, this you have the, for example, you have the land available. Not like you bought it, like you have a space that is feasible for a carbon project. They are there to invest in you, so that you, for example, maybe you've identified a huge galamsey site that has been filled, but it's just there, and you write a proposal to. There are a lot of organizations that are having this money on their account. For example, the Singapore government signed an agreement with Ghana in order to buy our carbon credit from the forest that we are having. So they have a big organization have the money there because of the pollution, the carbon offset that they want to do. So maybe, for example, Microsoft is having, like, I'm giving an example, 50 million there in the account, waiting for a good carbon project, someone to propose a good carbon project, and they invest in it. And in this case, how you benefit is you that wrote the proposal will benefit. There will be some mapping, there will be some verification, there will be a lot of works there that's the one that creates the money. And also you talk about how Ghana can, like, in this carbon market, how can we gain from it? So I will give you some figures. The Ghana recently secured a $4.8 million from the World Bank Forest Carbon Partnership for a carbon that's in 2019 for 972,500 tons of carbon that will reduce for our first monitoring. And in Ghana, the market is being estimated that is projected to supply our forest, or the greens that we are having, is projected to supply about 33 million tons of carbon dioxide in 2023 alone, and that will unlock approximately 500 million in capital. So there's a lot. And also the Cookstoke project that I talked about the Ghana, Switzerland one, and also even the initiative like planting trees that the government launched. These are all being funded by international organization because of the carbon offset that they want, or carbon credit that they want. So in terms of the potential, Ghana is having the potential. That's why the investors are looking here, because we have the land, we are in the tropical zones, and we have lands that are good for carbon potential projects. And if you have the project, you just write a good proposal, read more, and also before you do that, you have to also do your research and a few feasibility studies with a simple knowledge on it, and you write a proposal. Some companies are having money in their account just to invest in it. So that's how I can answer your question. I hope I answered it well.
To add to that, Godfred, the carbon office, though hasn't been long, is also increasing or improving in terms of capacity. What some of us have been arguing for is that they would have a database of carbon credit ready market, so that if you have projects, you can go there and sign on onto some of this project. The voluntary market is quite volatile, and as I said, just you can have a farm and take advantage of how do you call it, the carbon credits. You can just say I'm planting trees, and it can be deemed as carbon credit worthy. Two, it is creating jobs. The last carbon credit work on stove distribution has more than I think 100 or so people, aside the local people that it's employing. So it's creating job. I have been on a good standard verification, so it has created a job for me. And another side we spatial scientists can look at is the environmental impact assessment and auditing. Yeah, that is also something that's is another door that is opening for spatial scientists who would want to enter into the carbon credits market.
And Theo, I want to add to this one. And Theo mentioned something about the carbon office in Ghana. You know, though they are working towards like doing bigger things, but another thing that investors are having the money, but some are not ready to come. We don't have data to show the potential of the country or do analysis, and this comes into this presentation, the MRV system. If like a system is being developed in such a way that you use satellite data, use this data to tell an investor that this area, this is how much the potential that it has. And also to add to it, you are talking about planting trees. Don't think about like you go and collect the money, plant the tree today, and you cut it in the next 10 years. Carbon potential projects should be lasting like 50 years, because they are looking at the long term, not the short term. So all these analysis will be taken in consideration. So don't be thinking, okay, I'll just go and collect the money, and the money won't come like you planted the tree, so it'll be giving it to you. It's based on the potential or the carbon the carbon calculation that is being done. That's how the money will be dispatched. So it's a long term. If you are thinking of the tree plants, long term thing. That means that land cannot be used for anything. The trees will be there.
Exactly. The another even good thing to look at is one. Last week we were discussing that there is not an available geostatistical model or whatever over the country to even show investors come and they want to do some of these cook stove distribution, but they would have to know the poverty index and whatever, and there is no spatial output out there. So that is another opening for we the spatial scientists. When we go and they go and distribute these tools, they take coordinates, they map these households. That is also another area for spatial scientists.
Okay. Thank you so much for the responses. Engineer Marian Edem, she's asking that, is there a way for individuals or small businesses to contribute to or benefit from voluntary carbon markets?
As I think the answer was in so
Yeah.
I'll just say it again. So
Okay.
if an individual you want to contribute into this voluntary one, as I said, is capital intensive, which is not on you. It's on the investor, which they don't care. What you have to do is just give them a project, a feasible project. Just maybe you can get a land, go. He said, I think I understand now. So Engineer Jan, he just wrote that she understands now. So thank you.
So it's been clarified. She has gotten it now.
Yeah, I think the first explanation that I did was all inside. So
Yeah.
Please,
Can I add just
Okay.
follow up? Godfred and then TF from what you are
they
saying.
said to protect their
Please.
hello.
Hello.
Please go ahead. That's
Everyone.
one. Go ahead.
Okay, so from what you are saying, it looks like what you are talking about needs a lot of expertise to be able to.
That's why I'm doing this presentation to like expertise like us, and not only as a geomaticians. You need environmental guys. You need
you need to have a lot. You need to get a lot.
Yeah.
Forestry.
Yeah. Okay. All right. Thank you very
Someone
much.
has asked a question. Okay. Tio, are you on the floor? Dr. Tio, are you on the floor now? Someone has asked a question. He said she joined late, but with regards to satellite sensors, you want to know what is the current capability of satellite remote sensing to detect changes in above ground biomass in degraded or regrowing landscapes?
Yeah, so now satellite like Sentinel and Sentinel are being used for the calculation for the above ground biomass. But in order to get a more accurate one, you have to augment it with some field data, such as if you don't have the terrestrial scanner and you want to do the manual tree survey, or you want to use a normal area lidar to fly a place to get the tree density, then now you can use allometric calculation equation to do estimation for the whole project. Yeah, you can do that to do the above ground, but you can also use the Sentinel and the JIDA in order to calculate the biomass, but the accuracy won't be as close as someone who has combined it with the ground data.
Okay.
Integrated.
Okay. Any other questions? It's 8:30 now. Okay. Please, you have a question. Go ahead. Any question? Yeah. So she says, great. Thanks for the clarification. Another question: which satellite sensors provide the most reliable data for carbon stock estimation, and under what conditions?
I would say it's based on because I would say I will go for a higher resolution for a high resolution images for my stock estimation. But these high resolution satellites are all commercial. So it's also based on your budget also as well. So that's why the Sentinel that's 10x10 is being used, because it's a free one. And also you have to also take into consideration which area are you doing this carbon stock. That's where the SAR come in. If it's cloud, it's more cloud there. That means even if you use a commercial one that is a high resolution, there will be still clouds in there. That's where you also go for SAR. So the conditions will tell you the best, the conditions of the place that you're doing the project will tell you the type of satellite that you will go for. So it's not like you go for the satellite. If I say Sentinel, the optical Sentinel, you go there and there will be clouds. That means you have to use the SAR also. So, and I would tell you that use high resolution, but maybe your budget won't meet it. So yeah, it's also based on the conditions and the budgets of you.
Okay. Thank
Chairman,
you.
I think there's
Engineer
a question
Maulia.
from Dr. Damwa.
Yeah, before we come to the question, someone just said that today is Engineer Godfred's birthday. So let's wish him a happy birthday. I didn't get a notification on Facebook. Happy birthday anyway. May God bless you.
Thank you.
And then
I think Engineer Damo's one
Prof. Damoa is asking that what happens if they buy credit from you and unfortunately your tree stand gets bent through bushfires?
I want to take that question. So
okay.
The carbon project spans for a number of years. So in whatever you do, even in the something like a cook stove, if they give you a cook stove today and it's destroyed, the supplier has to come and replace. So some of them are for 4 years, 5 years. So when you sign onto the contract, it's for a number of years. So if within that period of years is when something is destroyed in the contract, it's part of the clauses that you would replace. So you replace the trees that are bent. I mean, the budget covers for all those things. Yeah.
Okay. Another one from Engineer Marion says, considering that voluntary carbon markets are unregulated, who is responsible for ensuring the accuracy and honesty of the carbon offset claims? And how is fraud or over-reporting prevented?
That's where Vera and Gold Standard comes in. Those are the regulators now. Vera and Gold Standard before they accept anything. That's what I think Tio explained. Before someone comes to see that okay, this carbon thing is feasible, you go to Vera. Vera has like a verifier to verify it for him. It's like they have the standard now. Vera and Gold Standards are the standard for the voluntary carbon market. So yeah, they ensure that these frauds and over reporting are being prevented. So that's why when you are doing a carbon project, it goes to a rigorous process and it doesn't end there that okay, now they've given me the money, I'm starting it. It's a continuous thing. It's being monitored. It's being monitored every time.
Okay, thanks for the feedback. Thanks for the response. I'm sure Engineer Maran, you're clear with that now. It's 35. Yeah, so I think she wants to hear the word well. Is it Vera? The regulator, Vera.
Verra.
Verr. Okay. All right. So the pronunciation will be Vera actually.
Yeah.
Okay.
Yeah, I think
is it an
someone
abbreviation?
asked a question, what's the calibration method using to validate satellite carbon estimation? So that's a good question. So satellite calibration, some use like LiDAR data is being used because, for example, you're using the satellite data to do a carbon estimation. In order to know that okay, this satellite data that I'm using and this estimation that I'm using, what's the accuracy of it, you have to go take a sample plot, go there, do maybe you can do a tree count if you are not having the terrestrial LiDAR, do a tree count, or you can even fly an area LiDAR, which will be able to give you the plant, the tree density. And now you can usually calibrate the satellite data and know that okay, if I see this kind of vegetation or this kind of image, it stands for this density. So that's something that you use to do the calibration for satellite-based derived carbon estimates.
All right. Do you have any other questions? It's almost 8:40. It's getting late. I'm sure we've learned so much. Interesting presentation and amazing questions. And then from the answers to all of us are learning. If there's any other question. Engineer Shine. So today I didn't see, or he didn't join us. So we are Shine. Shine couldn't join. Is Anita, you're online, but we haven't heard from you. Okay. Is there any question or any suggestions, any comments? So that we wrap up. Okay, so there's one message. Okay, so he's just saying thank you. It's getting late now. It's almost 8:40 and we should be wrapping up. At least we've done more than 1.5 hours of presentations and then questions and answers. Thank you so much. Thank you everyone who made time to join this technical presentation. And I must say that I'm most grateful. I know everyone is busy, and despite your busy schedules, you still made time to join. And I would like to also use this opportunity to say a very big thank you to Godfred Addai. Even though he's not here, he still made time to do this presentation for us. And it goes in our credits as Geomatic GHIE. Thank you so much. We are most grateful. And we hope to see you some other time.
Thank you for the opportunity. Yeah, see you another time. Thank you.
Okay.
Thank you for everyone for making time.
Okay. In the absence of any other thing, I want someone to move so that we can close our presentation. Anyone to move for closure?
Hi, this one, Prince Apedu. Move for the closure of this meeting.
Okay. Thank you. And it should be seconded. Who is seconding? So we close. Okay. Engineer Amavi, you've seconded. Thank you so much. Okay. Thank you all. And may God bless you. Have a good night.
Very good night. Thank you. Bye.
Okay. Bye-bye.